Imagine looking up at the sky and spotting a bright object with a long tail. Wouldn't that be fascinating? Well, in September 2023, Comet Nishimura gave us exactly that unique spectacle. But if you thought that such exciting visitors from space could only be spotted by special telescopes and trained astronomers, think again. The amazing story of Nishimura shows that any of us can become a comet discoverer in no time at all. But if you're annoyed that you missed the brilliant space visitor back then, we have some good news for you. Swan 25F, the next comet, is already on its way. So be sure to stay tuned until the end if you want to know when the celestial body will appear in our earthly field of vision and how you can observe it yourself. Whether it's Neowise in summer 2020, the Christmas comet Leonard the following year, or Halley's Comet, which makes a detour to Earth every 75 years. From time to time, these frosty chunks from the outer regions of the solar system come so close to us that we can even marvel at them with the naked eye. As soon as these objects enter their eccentric orbits near the Sun, the heat from our gigantic source of warmth and life causes frozen gases and dust to evaporate from their surface, forming the characteristic comet envelope, the so-called coma, and the tail. But how do we actually spot these colloquially named tail stars? Well, that always depends. Basically, most comets are detected during professional sky surveys. They are often discovered through systematic, automated searches for celestial objects, especially potentially dangerous Earth-crossing objects. But our space probes also provide us with important information for comet research. For example, the NASA probe Stardust, which in 2006 succeeded for the first time in collecting material from the comet Wild 2 and bringing it back to Earth for investigation. In 2014, Churyumov-Gerasimenko became the first comet on which a probe landed, as part of ESA's Rosetta mission. However, despite these highly professional comet investigations by NASA and others, we should not forget that space probes or special telescopes are by no means always necessary to track down these icy relics from the early days of the solar system. Sometimes all it takes is a combination of an ordinary camera, a good dose of luck, and a keen eye. An extraordinary chance discovery. On August 12, 2023, Japanese amateur astronomer Hideo Nishimura decided to photograph the night sky with a normal SLR camera, mind you. When he looked at his photos, he noticed a remarkable detail on one of them that immediately caught his attention, a faint spot of light that had not been there before. But that wasn't all. When Nishimura looked at the photos he had taken the day before, he noticed that he had actually captured the mysterious object then, too. This exciting news quickly spread, and it soon became clear that Nishimura had discovered a previously unknown comet, which was about 10 astronomical units away from the Sun at the time of its discovery. To put this into perspective, 1 astronomical unit, AU, is the average distance between the Earth and the Sun, around 150 million kilometers. In the days that followed, the celestial body was spotted and photographed by numerous other observers in Japan, the US, Australia, and Austria using telescopes. But strictly speaking, we could have added the object to the star charts much earlier. In fact, the comet was subsequently identified in archived images from the Pan-STARRS telescope in Hawaii and the Palomar Observatory in California. The corresponding images had already been taken in January and March. Well, better late than never. Comet C/2023P1 Nishimura. Further analysis revealed that we're dealing with a long-period comet. It orbits the Sun in an eccentric orbit that takes it as far as 110 Australian dollars into the outer solar system. As a result, Nishimura can only be found near the Sun every 435 years. Before its sensational discovery, this was last the case in 1588. The fact that it took us so long to find Nishimura, despite all of our state-of-the-art observatories, was due to the direction from which it came. It followed a course on which the Sun strongly outshone all other objects. How Nishimura appeared in the sky. Just how overwhelming the sight of a comet in the sky can becomes clear when we turn back the clock to October 1965. At that time, a cosmic chunk entered our realm and was so bright that it was clearly visible even during the day, next to the Sun. All in all, IKEA, Seiki reached 60 times the brightness of the full moon, making it not only the brightest comet in the 20th century, but also one of the brightest comets of the entire last millennium. The sight of Nishimura, on the other hand, was somewhat less impressive. Although it was only visible as a small, faint spot of light, it could still be seen with the naked eye from dark locations. However, the principle of the early bird catches the comet worm applied here. Anyone who wanted to marvel at Nishimura itself had to look toward the eastern horizon in the constellation Leo at around 5 a.m. But if you had binoculars or a telephoto lens at hand, you could not only admire the comet as a bright spot, but also see its green color and the glowing coma more clearly. The same was true of the characteristic tail of ionized gas and dust, pointing away from the sun. Speaking of the sun, Nishimura reached its closest point to it, known as the perihelion, on September 17, 2023. At that point, it was only 33.7 million kilometers away from our host star, moving within the orbit of Mercury. Even before that, on September 10th, the comet had approached Venus to within 80 million kilometers. Its closest approach to Earth occurred 2 days later. At that point, Nishimura was only 125 million kilometers away from us and appeared particularly bright as a result. However, as it continued to move closer to the sun, the comet disappeared from view from our perspective. It was so close to the sun that it rose together with it and was completely outshone. Later it reappeared in the western evening sky, but only briefly, very close to the horizon in the bright twilight, and was therefore barely visible. The next observations were not made until the end of November by observatories in the southern hemisphere. But by then, Nishimura had already lost much of its brightness. The last observation to date was made in May 2024 with a remotely controlled eye telescope at the Siding Spring Observatory in Australia. By this time, however, the comet had already moved $4.20 away from the sun. And so it is that we must now wait a little longer before we can marvel at this special visitor from space with our own eyes again. First, Nishimura will reach its furthest point from the sun, known as the aphelion, in 2226. It will then be around 16.4 billion kilometers away from our central star. Another 200 years will pass before Nishimura returns to us. Experts predict that its next perihelion will take place in April 24-29. A new visitor from space, Comet Swan 25F. The good news, however, is that we can shorten the waiting time by observing a completely different visitor from space. After all, the next comet visit is just around the corner. In the case of Nishimura, it was an amateur astronomer with a reflex camera. But this time, it was an Australian amateur stargazer who had examined the publicly available data from the Soho Solar Observatory. Although it mainly focuses on our parent star, its Swan UV camera is also capable of imaging comets. As soon as the ice on the surface sublimates, the ionized hydrogen releases ultraviolet radiation, which appears as a bright spot in Swan. And it was precisely such a bright moving spot that Michael Matiazzo spotted in the Soho data at the end of March. However, as he was unable to verify the comet from his location, he shared his discovery with other amateur astronomers. Soon after, the first images of the newly discovered chunk were taken from Earth, and it has since been listed under the provisional designation Swan 25F. We created this video for you in mid-April. The comet is currently visible as a small green dot in the morning sky shortly before sunrise. However, you will need binoculars or a small telescope to see it at the moment. But as Swan 25F is getting brighter, it may soon be visible to the naked eye. More precisely, the comet is currently flying through the constellation Pegasus, where it can be seen near the brightest star Alpheratz. On May 1st, Swan 25F will pass through perihelion. Initial orbit calculations indicate that it will then pass the Sun at a distance of only 31 million kilometers. During the same period, the comet will also reach its closest point to Earth. However, because it will be so close to the Sun, it will be very close to the horizon and will most likely disappear completely from our field of vision for several days. However, If Swan 25F survives its approach to the sun, it could appear in the sky in the early evening hours starting in early May. And because it will be on the other side of our host star, as seen from our perspective, it will appear on the western horizon shortly after sunset. And now, the subscribe button appears below our video horizon. Simply click on the thumb and then unsubscribe to never miss a new post from us again. We'll see you soon.